Welcome to the course Excelling with Mathematical Modeling. Today we will be talking about mathematical models of rumor. So, what is a rumor? So, I am sure you all know what a rumor is, but the definition goes like this, that it is a form of social communication and can shape the public opinion and affects the belief of an individual, which can lead to the changes of individuals' attitude towards economic, political and social aspects. So, a rumor is an unconfirmed truth and has negative impact on society, though an intervention can be implemented to minimize the negative aspects or negative impacts. So, we will use here mathematical model to understand this spread of rumor and to figure out some strategies that how to reduce its negative impact on society. So, to start with, let us divide the individuals into three categories. The very one first is ignorant. So, ignorant are the ones who doesn't know about the rumors. Then comes the spreaders. So, obviously, the spreaders are the ones who spread the rumors. And the third category, we name it as stifler. So, stiflers are those guys who already know the rumor, but somehow they lost interest in spreading them. So, with these three categories, we now form our differential equation. So, this is the rate of change for the ignorance who doesn't know about the rumor. This is the rate of change of the spreaders, and this is the rate of change for stiflers. So, we assume that there is a constant input of this ignorance, let us call it lambda, and when the ignorance are coming in contact with the spreaders, so they came to know about the rumors. So, some beta times I times s with a negative sign, because when the ignorants are coming in contact with the spreaders, they come across, they get the rumor and then they comes to the category of spreaders. So, here it will be beta I s, and then we put a natural death of the ignorance. Similarly, a natural death of the spreaders. And a part of the spreader who has lost the interest, they do not spread it anymore, they becomes the stiflers. Let us put it say alpha times s, and they come to the stifler group, and this is the natural death for the stiflers. So, we have taken the same natural death for simplicity for all these three categories. So, we have a model for the spread of rumor. So, let us now get into the analysis of the model. So, as explained before, so this is the ignorant, this is the spreaders, and this is the stiflers. So, let us put this as say our f, this is our g, and this is our h. So, the very first thing is we find the equilibrium points. So, we put this expression equal to 0, this expression equal to 0, and this expression equal to 0. And if you solve them, you will get the equilibrium points to be lambda by mu 0, 0 and alpha plus mu times beta, beta lambda minus mu alpha plus mu divided by beta alpha plus mu, and alpha by mu beta lambda minus mu alpha plus mu divided by beta alpha plus mu. So, we have two equilibrium points, and now we will be doing a stability check. So, this can be easily shown. You just put lambda minus beta is minus mu I equal to 0, then beta is minus alpha s minus mu s equal to 0, and alpha s minus mu f equal to 0. So, we start our stability analysis with this equilibrium point. So, our Jacobian matrix A is going to be del f del I, del f del s, del f del f, del g del I, del g del s, and del g del f, del h del I, del h del s, and del h del f. Our equations were di dt equal to lambda minus beta is minus mu I, which is our f, del s del t equal to beta is minus mu s minus alpha s, and df dt equal to alpha s minus mu f. This is g and this is h. So, we just partially differentiate this and substitute it here, and we will get this as minus beta s minus mu minus beta I 0, beta s beta I minus alpha minus mu 0, 0 alpha minus mu. And they need to be calculated at the equilibrium point I star, S star, and F star. So, I replace this by the equilibrium point. So, now we look for the stability analysis at each of these equilibrium points. So, the first point is lambda by mu 0, 0. And if we substitute it in this matrix, we will get A equal to minus mu minus beta lambda by mu 0, 0 beta lambda by mu minus alpha minus mu 0, 0 alpha minus mu. And I have to find its eigenvalues, which will be given by A minus lambda I, and determinant of this value equal to 0, which will imply minus mu minus lambda minus beta lambda by mu 0, 0 beta lambda by mu alpha minus mu minus lambda 0, 0 alpha minus mu minus lambda. And if we just solve this, it is just easy because these two are zeros. So, just expand along the first column and you will get minus mu minus lambda beta lambda by mu minus mu minus alpha minus mu. Let us put this as some x because I already have a lambda here. So, I will put an x minus some x and minus mu minus x equal to 0. So, this will give me the values of x to be minus mu and beta lambda by mu minus alpha minus mu. Now, as we can see, this value is negative, this value is negative, and if the system has to be stable at the point lambda by mu 0 0, this has to be negative, and condition for that is this must be less than 0. So, the conclusion is that system is stable about lambda by mu 0 0 if beta lambda by mu is less than alpha plus mu, and unstable if beta lambda by mu is greater than alpha plus. So, this is the condition which need to be satisfied for the system to be stable and for the system to be unstable. Let us move on to the next equilibrium point, which is alpha plus mu by beta, beta lambda minus mu times alpha plus mu by beta alpha plus mu, and alpha by mu into beta lambda minus mu alpha plus mu divided by mu alpha plus mu. Now, please notice that this is a positive quantity, and since they represent the population, this has to be positive and this has to be positive, and condition for that is beta lambda minus mu alpha plus mu, they has to be positive. So, for the existence of the equilibrium point, this one, this condition must be satisfied. Otherwise, the population will be negative, which does not make any sense. So, now we do the stability analysis, and if we calculate the Jacobian matrix A, this will give me minus mu minus beta lambda minus mu alpha plus mu minus alpha minus mu 0 beta lambda minus mu alpha plus mu divided by alpha plus mu 0 0 and 0 alpha minus. The characteristic equation will be given by so it is advisable if you want to calculate the eigenvalues, it may give you some complicated expression, then go for this characteristic equation. So, if you calculate this characteristic equation, which will be A minus say x I equal to 0, where x is the lambda is the eigenvalues. So, the equation will be of the form x plus mu alpha plus mu times x square plus beta lambda into x plus alpha plus mu times beta lambda minus mu times alpha plus mu. This is equal to 0. So, from here we can clearly see one of the root is minus mu, and we get a quadratic equation alpha plus mu times x square plus beta lambda x plus alpha plus mu beta lambda minus mu times alpha plus mu. Now, if you recall the stability criteria, which were like x square plus a1x plus a2 equal to 0, the Routh Harvey's condition or criteria. It says that an equation of this form will be stable if A1 is positive and A2 is positive. Now, in this particular case, as you can see, if I divide it by this, this is positive. So, we rewrite this equation A square plus beta lambda by alpha plus mu times x plus beta lambda minus mu times alpha plus mu equal to 0. So, this quantity is positive as all the parameter values are positive, and this is also greater than 0 due to the existence of the equilibrium point, which we have already shown here, that beta lambda minus mu alpha plus mu must be positive. So, this equation satisfies the Routh-Harvey's criteria, and the system is always asymptotically stable. About the equilibrium point, we call it the endemic equilibrium point. Or you can say the non-zero equilibrium point in this particular case, because endemic we generally use when we take a disease or disease model. So, since it is a Reumer model, we say that non-zero equilibrium point. Now, let us see about the numerical solution of this particular Reumer model, for which we will be using the Microsoft Excel. So, I already have it opened. So, as you can see, this is the first equation of the ignorance, these are the spreaders, and this is the Stiflers. Now, initial condition, though I have put n here, the value I have chosen to be 1000. Say there is only one spreader and no Stiflers. So, here is the initial values at time t equal to 0, the ignorants were 1000, only one spreader and no Stiflers. So, this, let me calculate, this will be 0 plus 1. This is going to be this initial value plus h is 0.1 and it is a constant. So, I put a dollar multiplied by, open a bracket, this whole thing. So, lambda, which is 0.3 and again a constant, minus beta, which is 0.008, multiplied by I, which is 1000, multiplied by S, which is 1, minus mu times, which is a small value, multiplied by I. Close it and enter. So, the next value is again S0 plus h times, which is a constant, multiplied by this whole thing. So, beta times I into S minus alpha S alpha S minus mu into S. And the Stifler's is equal to the initial value is 0 plus H multiplied by this whole thing, alpha times S dollar alpha times S minus mu times F. And we drag all this, it will generate a series of values. So we take it up to 150. So we get the values, and now we have to plot them. So I highlight these values by pressing the shift key and the cursor. Go to insert, the scatter diagram, and this one. So the chart title is going to be, so just click that, it is rumor model, the series, select data, click the series, go to ignorant, go to edit, and this is ignorance. Next one, edit, spreaders, and the last one, edit, Stiflers. And you get the numericals. If you want to remove the grid lines, go to plus and remove the grid lines. So this is how you generate the numerical figures. Let's move back to the explanation of this graph. So I've already copied and pasted the graph here, and the initial values that, so the ignorants are 1000, the spreader is 1, the Stifler is 0. These are the parameters of alpha, beta, and H. So what this graph tells? So the graph tells you that the ignorance started with 1000. So total population is 1001. So they ultimately goes to 0. That means all the ignorance they come across with the spreaders and then came to know about the rumors. And then comes the spreader. So they start spreading, and then slowly they also goes to 0, and because once you get the news, you spread, it becomes old, and then slowly you lose the interest. It is just like your WhatsApp thing. You get a message, the moment you get a message, you start sending it to your other groups and friends, and at one point, once you see that the message is quite old, you lose the interest, and that's where you form the Stiflers and go to an equilibrium point. So, at the end, all the spreaders ultimately becomes the Stiflers, but there is a peak, as you can see, that where the message or the rumors are being shared, and that is the peak of the spreaders, but slowly it also goes down to 0. If you now look into the stability condition, we have beta lambda by mu minus alpha minus mu. And we have shown that if this is positive, the system is stable about the non-zero equilibrium point, and if this is negative, then the system is unstable about the non-zero equilibrium point. Now, if we calculate this value, I substitute 0.008 multiplied by 0.3 divided by mu, which is 0.000005 minus alpha minus mu, 0.005. If I calculate this value, I will be getting 479.50, which is positive. So, this system is stable about the non-zero equilibrium point, but the question is, as you can see, that these are approaching zeros. So, the thing is, the values of the parameter are chosen in such a way that this goes to a very small amount, but they are never zeros. They are going to some very small value compared to this 1000, and hence your Stiflers, they reach this value 1000, where the other values are coming to a negligible value, which in the graph compared to this 1000 looks like 0. So, with this we come to an end of this very interesting rumor model. In the next lecture, we will be taking some more interesting model. Till then, bye bye.